Today, we are going to investigate a specific family of shapes called quadrilaterals, okay? Many of these quadrilaterals you will be very familiar with. You've known them since you learned shapes, but there are a couple that have some funky names and some funky features. Our goal is not just to look at it and go, ooh, that's a square. Okay, that's kindergarten work. We got that down pat. Your goal is to be able to explain why it is a square, okay? What is it about that square that makes it a square, okay? When you look at a rectangle, how do you know, hey, that rectangle is not a square, other than it just looks different? We're going to talk about why, okay? Putting some vocabulary to that. So here is your goal today.
In math, we are going to understand that shapes in different categories may share attributes, like having four sides, and that the shared attributes can define a larger category. We are going to recognize rhombuses, rectangles, and squares as examples of quadrilaterals. And we're going to draw examples of quadrilaterals that do not belong to these categories. Today, we're really going to focus on learning some important vocabulary, and we're going to begin recognizing types of quadrilaterals.
Okay, looking at these quadrilaterals and their attributes. So on Seesaw, you have an activity that is titled Quadrilateral Introduction. Quadrilateral Introduction. Go ahead and hop to that activity, please, and click on that Add Response button. Hi, Jalen, welcome. We are just starting. On Seesaw, you're going to go to an activity called Quadrilateral Introduction. Okay, go ahead and add that response. You're just in time, Bubba. All righty. Today, we are going to use vocabulary such as point and line segment to talk about different quadrilaterals and to define them. Let's take a look at slide 2, please. Slide 2 says, with a partner. With a partner, you are going to brainstorm shapes that you already know that have four sides, okay? Now, if you've been listening to me at all, I've already given you 2 answers. So you're going to brainstorm shapes you know that have 2 sides. You and your partners are going to draw as many of these shapes as you can, okay? So you're going to brainstorm the names of shapes that have 4 sides, and you're going to draw them together, all right? Okay, here you go in your breakout rooms. Screen sharing will be on. You should have talked with your partners about quadrilaterals, which is shapes with 4 sides. You might also have known that in the shape section, they have the quadrilaterals right there. Cheater. Anyway, we have rectangles. We have squares. Those are familiar. We have rhombus. We have parallelogram. And we have a trapezoid, okay? It says, can you highlight the line segments in red and the points in green? If you did not do that, I want you to go ahead and do that now. If you forget what that means, dun, 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 line segment, a straight figure that has 2 endpoints and is part of a line. Point, an exact location on a plane. Okay. If you forgot how to do this, let's go ahead and work on it together. If you remember, go ahead and get yours done alone. Line segment of the rectangle is each of the sides. Line segment of the square is each of the sides. Line segment of the rhombus is each of the sides. Line segments of the parallelogram are each of the sides. Line segments of the trapezoid are each of the sides. Finding the pattern yet? Yes, William.
So how's the rhombus different from the diamond? Because those two, the blue one and that one are the same thing, because it's just bigger.
What a wonderful question, William. We're going to learn that answer today. How are they different? We will find out. Yes, Steve.
These are like, some of these are literally shapes ever. Like a stretched out square, a square tilted on its side. I don't even remember what one that looks like.
I like it. You've got some familiarity with the shapes.
The one you colored.
All right, you got some familiarity. Let's take a look at points. Points are exact locations on planes. Remember, not a plane like, but a flat space. Your screen is flat. Points are going to be where the two line segments meet. Those points are going to be their end points. So on what we used to call the corners, we will now, because we are growing as learners, call them points. Okay? Corners are points or exact locations on, in this case, quadrilaterals. Points. Okay? Questions over the line segments or the points as they are related to quadrilaterals? All righty. Let's take a look at slide 3. Slide 3 has a short teaching video that we're going to watch that's going to help answer one of William's questions. How will I know the difference between a square or a rhombus or a parallelogram? And as we're thinking, I want you to be as we're watching, I want you to be thinking about how to fill in this sentence. Quadrilaterals are blank with blank blank. Okay, think about what could fit in that sentence.
Grammarly does more than...
Hush, you ads. There we go.
A four-sided polygon is called a quadrilateral.
Did you catch that?
A four-sided polygon.
I'll say it again.
A four-sided polygon is called a quadrilateral. The word quadrilateral is a combination of quad, which means four, and lateral, which means side.
Did you guys see it? Watch again.
Which means four, and lateral, which means side.
Dun, 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 dun.
Quadrilaterals are given specific names depending on whether there are parallel sides, equal angles, or equal sides. If all four sides are the same length, we call the shape a rhombus. When all four angles are the same, we call the shape a rectangle. In this case, all angles measure 90 degrees. All four angles are right angles. If all four sides are equal and all four angles are equal, the shape is called a square.
There you go, Will.I.am. The difference and why. Some shapes only have equal sides, but the points or the corners are different openings called angles. Some of them are skinny little angles, like this one, beep, beep. And then some of them are much wider angles, like that one. It's got to open, more open. So that is the difference. We define them by how their sides look or their segments, and then how their angles or their points look as well. Okay, 8 and G.
If you turn the rhombus a little and tilt your head like a little, you can see that it's like a square.
It is like a square in that it has equal sides. Yes, it does not have equal angles, but yes, all the sides are the same length. Very true. Yes, William.
Kind of what Aiden said, like if you could grab a corner, you could turn it and it would be a square.
So this would not be a square. It has the same sides, but those corners are not the same. Let me see if it'll let me annotate. So watch this. So we got this corner right here. Look at that. Look how skinny that is. You see that? And then look at this corner. You see how much more wide open that is? So this corner is like this, and then the corner on the square is a right angle or straight out. So they are the same in that the sides are the same length, but the corners are very different. Okay, and then look over here. This one, look how much wider that one is. See how different these are? Let me change the color here. Goodness, there we go. Take a look at this. Ooh, that's not a very good color. There we go. See how wide open that one is? And then look at this red one and look how teeny tiny it is. Okay, squares, all of them are the exact same size. On a square, they are all that right angle, that 90 degrees. So there are different, similar, but different. Okay, all right. I'm remembering why I don't ever use those annotations because they're a pain in my booty. There we go. All right. Go away.
In addition to classifying quadrilaterals by their sides and angles, there are also specific names depending on whether or not opposite sides are parallel. If one pair of sides are parallel, the shape is called a trapezoid. When both pairs of sides are parallel, the shape is called a parallelogram. Try and identify the following quadrilaterals. The rule of thumb is to use the most specific name when describing a shape.
What is this? Equal angles, rectangle. What shape is this? Trapezoid. What about this one? Careful, it's not a square, even if you turn your head. It's a rhombus. What about this one? Sides are the same. Square. Opposite sides are parallel. It's not a square. Even if you turn your head, it's not a square. It is a parallelogram. Oof. All different sides, all different angles. That's just called a quadrilateral. Sometimes we don't have a specific name for the shape if it doesn't meet that first criteria that we see here. Okay? None of those sides were equal. None of those angles were equal. So this is just simply a quadrilateral. None of those sides are the same size. None of those angles are the same size. So we call it a quadrilateral. All right. Now we are going to take a look back at our seesaw and record those notes. Ready? Quad means, if you were listening to the 4 times I played it, you would have heard that quad means 4. 4. Okay. A quadruped is an animal with 4 legs. So a dog is a quadruped. It's got 4. Okay. Your thighs have something called quads. It's the muscle, your quad. It is called that because it is composed of 4 muscle tensions that can be flexed. There are 4, okay? So quad means 4. Lateral means sides. I'm writing, you're writing. Quad means 4. Lateral means sides, okay? So a quadrilateral has 4 sides. Quadrilaterals, therefore, are shapes with 4 sides. And those sides are called line segments, okay? So quadrilaterals are shapes with 4 sides, and those sides can be described as line segments. I'll give you a moment to get that filled in. Okay. Quadrilaterals are shapes with 4 sides. On slide 4, we see a Brain Pop Junior. We are going to watch this, and you are going to have a partner conversation when we finish. Please take a look down here at what you're going to tell your partner. When this video is finished, you are going to tell a partner the most important thing about quadrilaterals. I think the most important thing about quadrilaterals is, and you're going to tell your partner. You are also going to tell your partner how line segments and parallel line segments can help you define quadrilaterals. So we're adding 2 vocabulary words today: parallel line segments and quadrilaterals. Okay, how can parallel help you define quadrilaterals? Here we go. Okay, be ready to share the most important thing about quadrilaterals. Be ready to share how parallel lines are connected to quadrilaterals.
Hey, Moby. I'm practicing my comedy routine for the talent show. Want to hear some jokes?
Big Chungus.
What did the rectangle say to the circle? I'll see you around. Thank you. I'll be here all week. Everyone loves jokes about shapes, am I right? What are quadrilaterals? A quadrilateral is a closed shape with 4 straight sides. Right, Moby. A square and a rectangle are both quadrilaterals. Both shapes have 4 sides. Remember, quadrilaterals always have straight sides. So these shapes aren't quadrilaterals. The sides of a quadrilateral can be straight up and down, straight across, or they can be slanted. What did the quadrilateral say to the empty room? Square is everybody. What is the difference between a square and a rectangle? A square has 4 sides, and each side is the same length. A rectangle has 4 sides too. The opposite sides are the same length. An angle is the place where 2 lines or sides meet. A shape can have different angles. One angle might be big and wide, and another might be narrow and small. The angles on a square and a rectangle are right angles. Why did the square miss class? Because she sprained her ankle. What is a parallelogram? When lines are parallel, they never cross.
This is that word parallel that I told you to listen to. So make sure you're listening for why parallel lines are important.
The distance between them is always the same no matter where you measure. This quadrilateral has 1 pair of parallel sides. If you extended those sides forever, they would never cross. But this quadrilateral does not have any parallel sides. You know, parallel lines have so much in common. It's a shame they'll never meet. A parallelogram is a quadrilateral with two pairs of parallel sides. A rectangle and a square are both parallelograms. They each have two pairs of parallel sides.
Okay, hope you caught that. A shape can fit into more than one category. A square is a square, but a square is also a parallelogram because those sides are parallel. Okay? If you really want me to blow your mind, a square is also a rectangle. We'll get to that soon.
The parallel sides of a parallelogram are equal. Why did the parallelogram go jogging? So it could stay in shape. What is a rhombus? A rhombus is a quadrilateral with two pairs of parallel sides and four equal sides. Right, Moby. A square is also a rhombus.
Woo! So a square is a square is a parallelogram, and a square is a rhombus. That's a lot.
It has two pairs of parallel sides and four equal sides. A rhombus, square, and rectangle are all parallelograms. Did you hear about the quadrilateral that got lost? It took the wrong bus.
Terrible.
What is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. A trapezoid can have a pair of equal sides or no equal sides. How do you catch a quadrilateral? You use a trapezoid. A square, rectangle, and rhombus are parallelograms and have two pairs of parallel sides. But a trapezoid only has one pair of parallel sides. You're right, Moby. All quadrilaterals have four sides, but they can look really different. Their sides and angles show how they're alike and different. What did one quadrilateral say to the other? What side are you on? You have a joke? Let's hear it. What do you call a shape that howls at the moon? A square wolf.
Okay. I'd like for you to go ahead and get ready to have that conversation with your partners. You are going to tell your partner, I think the most important thing about quadrilaterals is, you are going to tell your partner A and B. Line segments help you to find quadrilaterals because. Parallel line segments can help you to find quadrilaterals because. I will not be sending this in the chat because you have it in front of your face on slide 4. Okay, so just leave slide 4 open and you're going to talk about the 3 bolded items. Finish those sentences with your partner. Alrighty, I want to hear the most important thing about a quadrilateral. So this first sentence right here is what I want us to focus on right now. What is the most important thing about a quadrilateral? Read us that sentence, and then finish with your words. Aiden G, what is the most important thing about a quadrilateral?
The most important thing a quadrilateral is that a quadrilateral is basically like square, but it is like turned, but doesn't have even sides.
That is one type of quadrilateral. Yes. So there are many, many, many types of quadrilaterals. That is one of them. Okay. What is the most important thing about a quadrilateral? Daniel, what do you think?
A line segment.
Say,
I don't know because my person.
so Daniel, it's your thoughts. It says, I think. So what your partner did not matter here. What do you think is the most important part about a quadrilateral? You were saying something about line segments. What about them?
I think the line segment is important because the line segments have it's like a line and it goes all around the place. And
Good.
it's just a straight line.
Excellent. So the line segments are going to be straight and they're going to go around the entire shape. Daniel, how many line segments do quadrilaterals have?
1.
Check out our examples right here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2,
4.
4. Yep. Quadrilaterals have 4 line segments. Remember our defining feature here. Quadrilaterals are shapes with 4 line segments or 4 sides. All quadrilaterals have 4 line segments and sides. Thank you, Daniel. Wonderful. Okay. Line segments can help you define quadrilaterals because Daniel just kind of gave us that example, because there are 4 of them. There are 4 line segments on every single quadrilateral. They can help us define that. Now, what else about the line segments can help us? Here's a hint. What is different about the line segments of a rectangle and the line segments of a square? What is different about these? Terrence, what's different about the line segments of a rectangle and the line segments of a square?
That they don't have the same equal sides.
Which one doesn't have the same?
The square.
The square has all 4 sides are the same. These are all the same.
Rectangle doesn't have equal. There's
Perfect.
there's only 2 sides that are equal. Well,
Yes.
there are 4 that are equal, but there's 2 that are longer than
There's
the
2
side.
pairs. Yes, and we
Yeah.
call that pairs. Wonderful. So line segments, we can talk about their length to help us define quadrilaterals. A square, they are all the same length. A rectangle, they have 2 pairs with different lengths. Okay, wonderful. And we've talked about line segments defining quadrilaterals. What about parallel? Lines or segments that never, ever, ever touch or cross. How can parallel help us define those segments? William, how can the words parallel help us define quadrilaterals?
Well, parallel line segments can help us find quadrilaterals because they are straight angles.
Yeah, they're straight. They're straight angles. You're right, 180 degrees. They're flat. So a trapezoid only has 1 pair of parallel sides, and that is the purple ones that we see. A square has 2 pairs of parallel sides, the top and the bottom, the left and the right. So the number of parallel line segments being 0, 1, or 2 can help us define those quadrilaterals. Awesome. Let's take a look at slide 5 together, please. Slide 5 says, for each quadrilateral, identify line segments. Let's do that in red. Points. Let's do that in green. Intersecting lines. Let's do that in blue. And parallel lines. We'll do that in brown. Line segments, let's identify for each shape. For this rectangle, we have 4 segments. I'm going to write seg for short. I am writing, you are writing. For this trapezoid, we have 1, 2, 3, 4 segments again, 4 line segments. And for this trapezoid, we also have 4. 1, 2, 3, 4. 4 segments again. Let's switch to green and identify the points on these shapes. We have 1, 2, 3, 4. 4 points. Let's look at our next trapezoid. We have 4. 1, 2, 3, 4. So again, we have 4 points. So all quadrilaterals are going to have 4 segments and 4 points or corners. The same is true for our final trapezoid. 1, 2, 3, 4. There are 4 points. So all quadrilaterals, every single one, will have 4 sides and 4 points. If it has 4 sides and 4 points, it is a quadrilateral. Yes, Levin.
Trying to look at it, it kind of looks like a bow and arrow.
Yeah, I can see it, the stretch there. Yep. Intersecting lines. All right, everybody. It's an old dance move for you. I want you to hit the folks. Those are intersecting lines. Go ahead and do that. Okay. These are intersecting line segments right here. They are touching. They are crossing. Okay. When you give somebody a pinky promise, you have intersecting line segments right there. They are touching. They are crossing. Okay. So intersecting means they touch. Now, our line segments touch at the corners. We don't see them continuing on forever that direction, but we know that they touch, okay? Just like when you give someone a high five. You aren't crossing over their hand, but you are intersecting with their hand. You are touching that hand, okay? So intersecting, we're going to show where these intersect. Here, 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 and here. So our line segments intersect at the corners, at the points, okay? That is where these intersect. Let's show it on our middle trapezoid as well. Notice that those intersections look different. On the rectangle, they all made kind of an L shape. They just turned directions. On this middle one, some of them are way wider and some of them are skinnier. Intersecting is where they touch. Okay, so again, pinky promises are intersecting line segments. Hit the folks, intersecting line segments. Okay. Same thing here. That one's pretty skinny. That one's pretty wide. Let's switch to brown and let's identify our parallel line segments. A rectangle has 2 pairs of parallel line segments, 2 pairs. We have the top and the bottom are parallel. They're never going to touch. We have the left and the right are parallel. They are never going to touch. So 2 pairs of parallel line segments. Okay. Our trapezoids only have 1 pair. And it's a pair just like a pair of socks. A pair has 2 things in it. You got a pair of eyes, there's 2. You got a pair of socks, there's 2 socks. You got a pair of jeans, there's 2 legs. Pair, okay? This only has 1. Right here and right here. These will never, never, ever, 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 ever touch. It's only 1 pair. On this shape, they would touch. If we continued these on forever, those would eventually come to a point. So those are not parallel. But this kind of leftmost and rightmost parts are. Now I'm going to kind of erase some of my drawings right here so that we can see this a little bit better, because this one is a bit tricky. You know what? Let's just erase all this here. Here we go. On this one, believe it or not, we actually have 0 pairs of parallel sides. And the reason is, if we were to continue this on forever and ever and ever and ever and ever and ever, they actually get closer and closer and closer and closer to each other. Oops, that was a squiggly. Okay. You see how those are starting to, oh my goodness, I can't draw straight. Those are starting to get closer to each other. If we were to continue them forever, look at that distance. It's getting shorter and shorter, okay? So these actually have 0 pairs of parallel sides. 0. Let's go ahead and write 0. 0 pair. Okay? And that takes us to time. So let's talk about your task before I hop you off of here. On slide 6, this was supposed to be with a partner. If you'd like to do this for extra practice, go ahead. I'm not going to be checking this one though. I am going to be checking slides 7 through 12. On slides 7 through 12, you are shown a shape. You are determining if this shape is a quadrilateral or not. You will circle one. This figure is a quadrilateral, or this figure is not a quadrilateral, because, and when you fill in the because, I should hear this vocabulary. I should hear things like there are 4 line segments. I should hear things like there are 4 points. I should hear things like it is a rectangle. So this vocabulary I should hear on your slides. I will not hear every single word. Some of you guys have started saying, I know it's a figure because it has line segments, points, parallel lines, intersect, and you just read. And that's not going to help you because this is not a square. So don't just read this. Think about which words are true. And you're going to do that for each shape. Is it a quadrilateral or not? And how do you know? Okay. On slide 13, you have your success criteria. And as always, it tells you to use your mic to identify how you know you were successful. And again, you're not just going to read this because we didn't do all of this today. None of you classified quadrilaterals. None of you drew examples on this independent slides. The examples are there for you. So don't just read this, say what you actually did, okay? All right, that is your task for today.